Yeah, welcome back to Introduction of Sets Part 2. In the previous lecture, we have studied what is set and what is the notations for set, representation of set, and what are some important type of sets. Today we will see the operation on sets. So let's start. Venn diagram. What is Venn diagram? It is given on the name of famous logistician John Venn. It represents the relationship between the sets. So it gives the most of the relationship between sets. Generally, we represent universal set using rectangle and subsets of universal sets using circles. So Venn diagram give the relationship between the sets. It's a diagram representation. We represent the universal set generally rectangle and the subsets of the universal set using the circles. So this type of pictures we generally plot. This is suppose a rectangle. This rectangle will represent our universal set. I am using by this notation universal set. And suppose A is any subset of A. So I am representing A here. So representation of subset using circles and representation of rectangle universal set using the rectangle. Universal set we can take here like 1, 2, 3 up to 10. It is a finite set. And finite set can be represented by the roster form. So you can see that this is a roster form of the set representation. And suppose A is your set of even number 2, 4, 6, 8, 10. So 2, 4, 6, 8, 10 will be the inside A, and the rest element 1, 3, 5, 7, 9 will be the outside to the circle, but inside the rectangle because they are belonging to universal set. Next, I'm going to study here operation on sets. This is very important here. What are the operation of sets? I'm going to study here union, intersection, difference, complement. These are some important operations on sets. So let's start union of sets. It's a representation by this. This is representing union. This is the notation for union. It consists of all the elements of set A and set B. If we are going to find the union of two sets, this is the representation A union B, then the definition will be consist all the elements of set A and set B. Or if you want to write in the set builder form, so A union B collect all the element means all the X belongs to A union B, that X belonging to A or X belonging to B. So this is the definition of A union B. Means if we see the Venn diagram here, this is your A set, this is your B set, then A union B is the coloring of all the union of A union B is coloring A and B both here. This is your universal set. So this is the representation of union of sets. Or we can write it if X belongs to A union B, it gives X belongs to A or X belonging to B. And this definition is true from both the sides. Suppose we have set A is 2, 4, 6, 8 and set B is 6, 8, 10. Then A union B is going to be collection of all the elements in A and B will be 2, 4, 6, 8, 10. So if you represent here A union B, we have set A union B like this. This is our A union B here. This is set A and this is set B. One remark we have, later on this A union B we will study after some time. When we will see what is the intersection, then we will study more on union and intersection. Suppose B is the subset of A. It means what will going to be here? This is your universal set. B is inside A only because B is a subset of A. So A is going to be superset of B. Then if you take the A union B, it will be A only because all the elements belonging to B are also belonging to A. So it is not going to affect anything here. You can see that 6 and 8 are repeating here, but in the roster form I told you we do not generally repeat the elements. Let's see some properties of union of sets. Properties of the operation of union. First, it is commutative. A union B is equal to B union A. So satisfying the commutative property. Second, A union B union C is equal to A union B union C. It means associative property. Is also satisfied by the union notation. If you take the union with the null set, it is not going to affect anything. You will get A only. If you take the union of two sets, A and A, it will give you A only. If you take the union with the universal set, you will get only universal set. So union with the any set of universal set will give the universal set always. Let's see what is the intersection of sets. The intersection of sets A and B is the set of all elements which are common to both A and B. Means what is the definition? A intersection B take the all the element which belong to A and B also. But in the case of union, there is a OR option is in the definition. OR means with anyone, if it is there, it will belong to union of the sets. Suppose you have set A as 2, 4, 6, 8 and B is 6, 8, 10. Then A union B, what are the common elements? 6 and 8 are the common elements. So this will be the intersection of A and B. If we see using the Venn diagram here, this is universal set, this is set A and this is set B. What are the elements in the set A? 2, 4, 6, 8. What are the elements in B? 6, 8, 10. If you draw the elements, you can see that 6 and 8 are common to both. So 6 and 8 will be located here. And rest element of A will be 2 and 4 and the rest element of B will be here 10. So if you see the intersection portion is this one. So A intersection B is this area only, 6 and 8. And in the union, you have to cover all these two sets. It will give you 2, 4, 6, 8, 10. So what are the outcomes here? Till now I have studied if any element belong to A union B, then it will belong to any one of them. It belong to A or belong to B or both. If any element belong to intersection, it will give you X belonging to A and X belonging to B. What will happen if not belong? If X is not belonging to A union B, it means X is neither in A nor in B, means and X is not in B. Then only it will not be in the union. If any element is not in the A union B, you can see the Venn diagram also. Element is not here, not here. It means element is outside here in the universal set. Suppose universal set is 1, 2 up to 10. Then the other element will be 1, 3, 5, 7 here. 5, 7, 9 here. So you can see that if you say one is not belonging, हम चला लेंगे, नहीं हमें कुछ नहीं करना. So one is not belonging to A union B. We can see that one is not belonging to A and one is also not belonging to B. If it means if any element is not in the A union B, it will not be in A and not be in B. Similarly, if X is not belonging to A intersection B, if X not belonging to A intersection B, then we have three definition actually here. X not belonging to A or X not belonging to B means X is may possible not in A or not in B, then it will not be in A intersection B. For example, as we have discussed previously, this is your A, this is your B. In the A, the element was 2, 4, intersection 6, 8. Here it was 10 in the B, and the rest element 1, 3, 5, 7, 9 are outside to A union B. In the A intersection B, there are the common elements 6 and 8. So if any element, if we have three cases here, suppose that 3 we take. 3 is not belonging to A intersection B. We can see that. So we can see that 3 is not belonging to A and or 3 is not belonging to B here, or 3 is not belonging to A. If 3 is not belonging to any of the set, it will not be in the intersection. Here you can see that but if not satisfied with the one set only, then the other condition is meaningless. So we use or here. For example, if you take 2, 2 is not belonging to A intersection B, but 2 is belonging to A. But 2 is not belonging to B. So we will put and, because you can see that 2 is belonging to A, 2 is not belonging to B. So other definition will be, if X is not belonging to A intersection B, you can think like that. X is in A. So it is compulsory condition, other condition ki X must not be in B. Here if X is not in A, then other condition is meaningless. So we will put or here. Because if any element is not in the set, it means it will not be in the intersection also. Similarly, if you put X is belonging to A, then we have to put the condition. This is your condition. And is putting the condition and or is relaxing the condition. If X is not belonging to A intersection B, but you are claiming that X is in B, so we have to put condition that X is not belonging to A. Then only X will not in A intersection B. So there are three definitions, but this definition is important here. Let's see some other properties of operation of intersection. First is A intersection B is B intersection A. It means commutative property satisfied. A intersection B intersection C is A intersection B intersection C. It means associativity is also satisfied. If we take intersection with the null set, we will get always null set. If you take union intersection A, you will get the set only. And one most important property is, if you take, this is called distributive property, A intersection B union C, it will be A intersection B union A intersection C. This is important property called distributive property. See, if you take the set itself, both set are same, then intersection will be same here. One important remark is there. If A and B are two sets such that A intersection B is phi, then A and B are called disjoint set. This is very important definition. When two sets have intersection null set, then sets are called disjoint sets. Let's see some important Venn diagram for three sets. If ABC are three sets, then we are going to study some important Venn diagram here. For drawing the three sets, suppose this is your universal set. This is your A set. This is your B set. And this is your C set. This portion, orange color is representing here A intersection B intersection C. But if you add some red here, then red plus orange is representing here A intersection B. If you add here blue, suppose this is your blue, then blue plus orange is representing here A intersection C. If you add one more color here, suppose this is your purple, color, then purple plus orange color is representing here B intersection C. So this is the ultimately Venn diagram parts here. And what about this? This combined, if we use one more diagram I'm going to draw here, and try to give answer by yourself only. If we take, these are three sets A, B, C. If I ask you what is B union C, then B union C is going to be this one. B union C is going to be this one. Now my doubt is, this is your B union C. Draw another Venn diagram and try to take intersection of B union C with A. Intersection of A with B union C. So what will be the portion you will cover? Think. It's a very interesting problem. Intersection with A means you have to give the common part of A only here. So this part will be the A intersection B union C. So try to make some other Venn diagrams and color them. Let's see next definition. Difference of sets. If we have two sets A and B, then A minus B is defined as collection of all X when X belongs to A and X is not belonging to B. Or B minus A is collection of all X belonging to B and X is not belonging to A. If you want to draw the Venn diagram for A minus B, X is belonging to A but not B. A but not B. So this is the A minus B. What about B minus A? If you take B minus A, X belonging to B but not A. So this will be the definition or difference of sets. Let's see one example. Set A is 2, 4, 6, 8. B is 6, 8, 10. Then A minus B will be the elements belonging to A, not in B, not in B. So see the elements of A, 2, 4, 6, 8, but 6 and 8 are in B, so A minus B will be 2, 4 only. What about B minus A? The element in B but not in A, so you will get 10 only. Suppose A is ABC and B is 1, 2, 3. Many people confuse. What is your A minus B? Many people write 5, but this is wrong answer. Not in B. So no element is common. So A minus B will be the element belonging to A only. So this will be the A minus B. Important point. A minus B is not commutative. A minus B is not equal to B minus A. Next definition is complement of a set. A complement is defined by these two notations, A complement like this or this, and this is the collection of all X belonging to universal set but not belonging to A only, but not belonging to A. Means if you see the definition, this definition is matching with some different set. What is meaning? I told you the A minus B is the collection of all X when X is belonging to A and X is not belonging to B. So match this definition. A is universal set and B is A here. So A complement is nothing else universal minus A. So if you draw the universal set, this is your A set, then outside region to A will be the A complement. Or you can write A union A complement is nothing else universal set. Universal set. If you take the double complement, complement to complement, you will get the set only. So this is the definition of complement of a set. For example, suppose universal set is 1, 2 up to 10 and A is your previous 2, 4, 6, 8. What will be the A complement? It will be the remaining element 1, 3, 5, 7, 9, 10. This will be the A complement here. Next is De Morgan's laws are most important. First is A union B complement is A complement intersection B complement. And second is A intersection B complement is A complement union B complement. Union converted in intersection, intersection in union. This theorem can be proved very easily. These laws can be proved. I'm going to prove here first, taking the X belonging to A union B complement. Call A union B HC. Call it HC. Then X belonging to C complement. So if X is belonging to C complement, it means X is not belonging to C. You can see this definition. If X is any element belonging to A complement, then X is not belonging to that set only. Or X not belonging to A union B, because we have supposed C as A union B. I told you the definition, X belonging to A union B. You can see here. X not belonging to A union B, I told you. You can see previous slides. Then X not in A and not in B. It will not be in both. Then only it not be in the union. So if X is not belonging to A, it will be in the complement only. If X is not belonging to B, it means X is belonging to B complement. X is belonging to A complement and X is belonging to B complement. It means X is belonging to both. So X is the common element in A complement and B complement. So it means common means intersection. So X is belonging to A complement, intersection B complement. If we take it as a right hand side from both the sides, you can take from RHS and HS both the sides, you can prove this De Morgan law. So this is a very important law here. We have some other laws also called complementary laws. First, I told you A union A complement is universal set. A intersection A complement is null set. You can see that both have no part common. And complement of null set is a universal set. And complement of universal set is null set. So these are some important results. One most important remark I am giving you as a homework to try to prove it. If A union B is equal to A intersection B, prove that A and B are equal sets. Prove that A and B are equal sets. In the next lecture, we will study the application of Venn diagrams in solving many difficult real life problems, which will be useful in GATE aptitude also. Thank you.